Hello everyone. In today's session, we will be solving a problem based on the Reynolds number we have studied previously. So first, we need to note down the data that has been given. So read the question. We have a Ruston turbine impeller with a diameter of 0.5 meters. So write down the diameter of the impeller is given as 0.5 meters. Also, they have mentioned the broth has the properties of water, that is density. Density is rho. It is given as 1000 kg per meter cube. And they have also mentioned the viscosity, which is mu, 0.001 pascals. This can also be called as 1 cp. If the impeller rotates at 120 revolutions per minute, is the flow laminar or turbulent? They have simply mentioned the speed of the impeller, that is given as 120 revolutions per minute. So for 1 minute, the impeller is rotating at a speed of 120. Now, the most important thing, or the first thing we got to do here is we got to convert the units. Converting the units is the most important thing, because if you fail converting the units, you are going to get a completely wrong answer, and even if you solve the whole thing, you are not going to get any marks. This is the biggest trap. So the very first thing you need to do is convert the units. Here we can see the Ni. What is Ni? Ni is the rotation of the impeller. So Ni is given in 120 revolutions per minute. Okay, but we can see that the other properties, for example mu, it is given in seconds. Okay, so we need to convert this minutes into seconds. 1 minute, as we know, is 60 seconds. So therefore we can divide it by 60. Therefore Ni will be equal to 2 revolutions per second. So we knew that the impeller is rotating at 120 revolutions for 1 minute. So for 1 second it is rotating at 2 revolutions. Next step is you got to apply the formula. So we have learned the bioreactor Reynolds formula, as we have seen in the previous video. The bioreactor formula RE for a bioreactor will be Ni into Di, diameter of the impeller square, rho divided by mu. Okay, now let us simply add the numbers. Okay, so the Reynolds number RE is equal to, what is Ni? Ni is 2 revolutions per second, right, into what is Di? Di is 0.5 meters square, into what is rho? Rho is 1000 kg per meter cube. The most important thing is you need to write down all the units so that you don't miss any of them at the end. It is also like reassurance. After you write the unit, just check it out if you have missed anything. So what is mu? Mu is 0.001. Okay, so after you calculate it, we are going to get Reynolds number will be equal to this. You are going to get as 500,000. Okay, so we are going to get as 500,000. There is no unit here. Reynolds number is a dimensionless unit, because all of this is going to get cancelled. So hence The last step is interpretation. Interpretation. So what do you interpret from all of this? What do we interpret from all of this? If it is a stirred tank or stirred tank, for a stirred tank reactor, if the Reynolds number is less than 10, what it is called? If the Reynolds number is greater than 10, is greater than, 10,000, then what is it called? Okay, this is a key concept because if the Reynolds number is less than 10, then the flow will be laminar. Okay, if the Reynolds number is greater than 10,000, then it is fully turbulent. This is the key concept you need to remember. Okay, this is the key concept you need to remember. So what is our RE value? Our RE value for our stirred tank reactor is 500,000. So obviously it is, the RE is obviously greater than 10,000 in our case because it is 500,000. So definitely the flow is completely turbulent. This is the most simple form of explanation we can give for this particular problem. So we can say that for a stirred tank reactor that they have given us, if the impeller is rotating at 120 revolutions per minute, the flow is said to be turbulent. This is the final answer. I hope this is clear. Thank you so much for watching.